You're watching Power Nation.
In this episode of Engine Power, the king is back. Our Ford 300 returns for a round of serious upgrades as we get ready to push this engine for even more power.
Today we are going to go over our plans for upgrades, do some serious modification to our engine block, get it honed for our new setup, and give it a facelift as we prep this inline 6 for a big power dyno session.
Hey everyone, and welcome to Engine Power. Today we are bringing back not only one of our favorites, but by the views, one of your favorite projects that we've done. This is our turbocharged Ford 300 inline 6. Now, we did this a while ago and it made large power turbocharged, and now we are gonna bring it back for some upgrades. Now, we did inadvertently drive the cost up of every 300 in the country.
Sorry, not sorry, but this version, we're probably gonna do it again. This is going to be what we consider the ultimate 300 build. This is a dream build, throw the kitchen sink at it. All the best parts that the industry has created since our last version are going in this build, and it is going to be a killer. So we have laid out some of what we're gonna be using just to show you some highlights. Starting out, we have this beauty. This is a Pro Max Performance CNC ported cylinder head. They did a hand ported version for our last iteration, and quickly after created this CNC ported version. This is one of the very first ones, fully CNC ported intake and exhaust, and a little bit of work done to the chamber, some increase in flow, stainless back cut intake valves. We're gonna show you more of this later, but very excited to run this. That is gonna be paired with a beautiful stick of billet. This is a custom built, custom ground hydraulic roller cam from Comp Cans. They've actually had the specs to build these for years, but we reached out and had them build us a very special one with LS hydraulic roller lobes, and we got a set of their lifters to pair with it. To make the engine more durable for the amount of boost we're gonna be throwing at it, we also reached out to Molnar Technologies, got a set of their forged H-beam connecting rods, and those are gonna pair with a set of DSS Racing forged pistons. These were specifically made custom for a Ford 300 application for us, but they will quickly become a shelf stock version soon.
Also, we went wild on the induction side. We have an Offenhauser C-Series that we sent off to our friends at Wilson Manifolds. They have converted this one to sequential port fuel injection and also done some work in the plenum and the runners for us. Also, we picked up this absolutely gorgeous stainless steel exhaust header from our friends at Stainless Headers Manufacturing. Now, this puts the T4 flange exactly where we want the turbo for our application.
And like Pat said, we're gonna switch this engine to sequential port injection, and we're also gonna switch it to sequential coil-near-plug ignition. So all of that will be controlled by a Holley HP ECU. Like our Slant 6, we will have to build a custom harness, and we will build a custom mount for some Holley EFI smart coils. We are extremely excited for this build, and we cannot wait to get started.
But if you are not one of the over 4 million people who have seen this build and saw what is made, check all this out. This engine started out a little different than most, not as an automotive engine, but a steady state power plant mounted to an industrial sewage sprayer. It was originally run on compressed natural gas, but after getting it on a dyno cart, making a few checks and converting it to gasoline, we were able to make a baseline dyno pull yielding 88 horsepower and 217 pound-feet. For some cheap and easy fun, a few upgrades were installed in stages on the stock power plant, including an exhaust header, upgraded ignition system, roller rockers, and a 4-barrel intake. Combined, these immediately jumped the power up to 169 horsepower and 280 pound-feet of torque.
In the next version, we got serious and planned a full performance rebuild. The block was torque plate honed for a set of forged DSS Racing Big Block FE pistons. ARP rod bolts were installed in the stock rods. It received a custom ground hydraulic flat tappet cam. Pro Max Performance provided a ported late model cylinder head. The engine was dressed up with some fresh white paint, and it was finished off with an Offenhauser C-Series intake and the same long tube header. Naturally aspirated, the engine made 270 horsepower and 338 pound-feet, which was a huge improvement for a relatively affordable build.
Then the real fun started as we fabricated up a custom turbo system for our 300 and added in a Turbonetics Sylvia 7268 turbocharger, a Holley X-Flow throttle body EFI system, and a programmable boost reference distributor. At 13.2 psi of boost, the engine was a beast. making 522 horsepower and 597 pound-feet of torque on 93 octane gas. Even though this engine's been waiting in the wings, we always knew it would be back for more.
To get this newest version rolling, we are going to cruise through the disassembly process as we take our 300 down to the bare block for our upgrades. After removing the turbo system, accessories, and the intake and exhaust manifolds, the valve train is pulled to remove the cylinder head and inspect the cylinders after the abuse this engine has been through.
Continuing on, we can remove the oil pan, timing cover, and camshaft before flipping the engine over to remove the rotating assembly. All the rod bearings look spectacular on their way out, and the condition of the pistons is also an excellent indicator on how well the engine was holding up to 522 horsepower. Finally, the main caps are taken off and the crankshaft removed to round out the disassembly.
Up next, we knock out our block modifications, getting it ready for a hydraulic roller conversion, porting the oiling system, and trying something that's never been done before. Whew. Okay, you are probably wondering why I'm standing here grinding on our 300. Well, let me explain. We told you we're going to be converting this engine to a hydraulic roller cam, and the lifters we're going to be using are just a standard set of big block Ford 429, 460, 385 series comp cams retrofit hydraulic roller lifters. They have the correct diameter, the correct oil band height, and the tie bar spacing is correct for the application. The big thing that kind of becomes an issue, and the reason most people don't do this very often, is that the tie bar interferes with this bolt boss for the lifter cover. So what we have to do is we actually have to grind that down until it clears. So we've already got this one done. We took about 200 thousandths of an inch off of it. And you can see once we get it lined up, the tie bar just skates by. And then once it's in, it's really not a big deal. The lifters sit low enough. We have enough travel for the lift on our cam, but we have to make sure that that can clear on its way in and out. So we have this one done. We have 5 more to do, and then we're going to go through and do our normal process of deburring the block, porting the oil passageways and all of that before it goes in the cleaner for the first time. The easiest way to grind down these bolt bosses is with a large grinding disc and some paper towels to protect the critical areas of the block. Before starting, we did tap the threads of each all the way to the bottom to provide the most thread engagement possible once the material is removed. When we get close, a flap disc on an air grinder gives us a nice looking finish and allows us to sneak up on the amount needed to make the lifters clear. Each one is test fit with a lifter pair to ensure clearance, and with all 6 done, we can move on to our next block modification, porting the oil passageways.
We always do this on every engine build since it doesn't take much time and can significantly improve oil flow throughout the engine. We use a variety of carbide bits to go through and round off any sharp edges in the oiling system, like this inlet to the oil filter housing. Then we will go through and deburr any sharp edges on the entire engine using a hand file around the mains and a carbide bit on the rest of the engine to make it easier to work with and to reduce the chance of stress cracking. Once all of our grinding is complete, we can load up the block into our JRI jet washer to clean out any of the oil and debris. With our fully deburred block out of the cleaner and looking good, it's time to move on to our next operation. You might notice we have our torque plate all bolted up, and that would normally mean we're going right to the hone and get it sized up. But we're going to be doing something a little bit different. Back in the day, to reinforce stock casting blocks to make them live at higher power levels, you would fill the block with grout. And what that would do is you would fill the block from the bottom up, basically all the way to the bottom of the water pump hole, and that would encase the cylinder and reinforce it so it doesn't flex around and break. Doing that always takes the block out of street driving service because what happens, no coolant is going through the block, still going through the cylinder head, but the block becomes very, very hot, thins out the oil, and a bunch of bad things happen. Well, we are going to keep it in street use because we are going to be doing the actual inverse of filling it from the bottom up. We are going to be filling it and reinforcing the deck service. Sound a little bit confusing? Let us explain.
Yeah, the thought process here is that we want to actually add structure to the top inch or inch and a quarter of the block and leave the bottom open for coolant to flow. So like Pat said, we can leave this block in street use. We're doing that for 3 reasons. 1, we want to keep it in street use and allow coolant to flow. 2, we want to add thickness to the deck surface itself to help improve head gasket sealing under high boost applications like this one. And 3, most of the pressure from combustion happens in the first inch or so of cylinder. And we've actually done some simplified calculations on this, and you can see that at the boost level we think we're going to be running, and the cylinder pressure we think we're going to have, even by 3/4 of an inch or an inch down, most of that pressure is pretty much gone. So we're going to be filling it with some Moroso engine block filler that we got from Summit Racing Equipment. This is specifically designed to do this, and it has the same thermal expansion rate as cast iron, so it will shrink and grow with the block. Now, fair warning, we have never actually done this. We've never seen anything about anyone doing it this way on this particular block. It's relatively common in the import world for them to pack the coolant passages with salt or sugar and then pour about 3/4 inch of epoxy on the top on open deck engines where there's no structural support for the top cylinders. But in an application like this, we honestly have not tried it.
So what Frankie says is we're all gonna learn together.
Yep.
When filling a block, the first step is to make sure that the block is level in both directions. Then we will mix 2 cups of water into 1 bottle and shake it thoroughly to fully mix it. You want the filler to be runny enough to easily flow and self-level, but the less water you are able to put in, the stronger it will be when it dries.
In order to help the filler flow and to ensure no air bubbles get trapped in it, we will use an air hammer with a blunt tip on the side of the block to vibrate it. When we are happy with the level, about 1.5 inches below the deck, we can use water to clean up any mess, just like tile grout, and double check the level of the block before letting it sit to cure.
Coming up, we show you the ultimate rotating assembly for a Ford 300 and get our block honed for our big boost setup. With our block over there percolating, it's time to now concentrate on our new rotating assembly. If you remember, the last time we had this thing running in turbo fashion, we used the donor components out of the stock engine, and that included a cast, yes, a cast crankshaft. Also, we used the stock connecting rod out of the 300, which is 6209 long, 975 press pin. What we did improve on is the piston. We put a forged piston in it from DSS. This is for a stock bore 390 FE Ford. Worked great. This thing basically made 100 pound-feet per cylinder, and everything looked great. So you know, at that level, these parts will work great. But we are doing this as an R&D engine, so you can take all of this data and build an engine at any level you want, and you know what parts are going to work for it. Speaking of new parts, because we are going to step up the performance, we are going to step up the parts for this thing.
Yeah, and it all starts with a unicorn. If you are not a Ford 300 fan, you probably don't know what this is, but if you are, you know what you're looking at. This is a factory forged crank for the Ford 300 platform. These were very rare. They were only made in the late 60s and early 70s and used in industrial applications mostly, and they are extremely hard to find. Like needle in a haystack hard to find, but after our last version, we actually saw one pop up on the internet and immediately snatched it up. This is dimensionally the same as our cast crank, but being a forging, it is much, much stronger, which we really want that insurance for our bigger power level we're going to be shooting for. We have also stepped it up on the connecting rods. After our last Ford 300, Molnar actually started making an H-beam forging for the Ford inline 6 platforms, and for our application, we're actually going to be using the 240 version of that rod. It has a bushed 912 small end, 6/800 center to center length, and the big end is the correct size for our 2/123 rod journal. These also are upgraded with an ARP 2000 cap screw. So these were specifically designed for boosted applications like ours, and that 6/800 length is going to let us run a trick piston.
And speaking of trick pistons, they don't get much tricker than this for this application because they are custom designed for it. This is a DSS Racing 3FX series forged piston for this. It's made out of 2618 and it has the correct valve location and valve angle for the 300. They have their patented X groove on the skirt with an anti-friction coating. They also have the dish for the correct compression ratio that we're looking for, and also they have a thermal barrier coating on them. They have a 1.23 millimeter ring pack with a steel top ring for that high heat on the boost, and also a extremely heavy duty wrist pin. All this said and done, this is going to be great for our application, and we're really excited to get this thing together, but the first thing we have to do is balance the crank, and inlines are one of our favorite ones to do.
Unless you have to carry them up a hill.
That's why he's here.
It's okay, I get it. Since inline six crankshafts have journals that are evenly spaced 120 degrees apart, the mass of the rods and pistons are offset by each other, so no bob weights are required for balancing. All right, that's pretty good, especially for something this old, but 0.680 ounce-inch on the left and 0.762 ounce-inch on the right. They are together, but it shouldn't take much to correct that, so we'll get after it. We will make all of our adjustments with an angle grinder to remove mass from the counterweights and finish it off with a flap disc to have a clean, smooth finish. We only have to remove weight in a few areas on the crankshaft to pretty soon have it dialed in for our street application. All right, that we will 100% take. 0.055 ounce-inch on the rear, 0.071 ounce-inch on the front, 173 degrees apart from each other, well within our tolerance. Very, very good for this inline six that's going to turn relatively low RPM, so we'll get this off and get it cleaned up.
With our block solidified, it's in the hone and we're getting it roughed out. Now we've already put our 150 grit diamond abrasive through it and got it almost to size. We are going to change up our surface finish in the cylinder on this one a bit because of its application. So with everything to where it's supposed to be for size, we're going to change out to our 600s and get her finished up. After changing out our sun and diamond abrasive to the 600 grit set, 5 finish strokes in each cylinder at lower speed and load will set the proper surface texture for this application. After cleaning the boards just like final assembly, we can measure our surface finish with our TraceBoss software from Total Seal. All right, that is exactly what we were looking for on this. This particular application has a different cylinder finish than, say, a naturally aspirated one. We're having the valley of the actual groove or scratch in the bore at a deeper level, which this one is 77 on our meter. Our load-bearing surface of the cylinder, RK, is in the 40 range, so we are spot on for our application.
Stay tuned, because up next, we dive headfirst into our inline six build and redo its classic look.
Cast crank.
Forge crank.
Cast crank.
Forge crank.
Which one is better?
Which one do you need?
That is the subject of today's Summit Tech Tip.
Now, you've heard us throw around the terms cast and forge quite a bit on the show, but we get a lot of questions about it, so we wanted to talk about the differences with some examples from our 300.
First, we're going to talk about a cast crankshaft. Molten material is poured into molds and then gotten into a general shape and machined from there. You can usually tell a cast piece like the crankshaft by its narrow parting line. Now, cast iron is great. It is affordable because it is cheaper to manufacture, but it will only take so much abuse from a performance standpoint. They're great for most applications, but when you want to make the big power, that's where forged comes in.
Now, the way they make a forging is they actually heat the material until it is semi-malleable, and then they press it or pound it into a set of dies to get the general shape that they want. Then from there, once it's cooled, they pull it out and fully machine it just like a cast crank. The benefit is, because it has a much denser material, it has a better grain structure, and is usually heat treated better, these can hold quite a bit more power. Now, the way they're usually identified is a wide parting line here that forms when the material is pressed into shape. These are a bit more expensive, but for a high performance application like this one, they are almost a must.
Both cast and forged cranks have their pros and cons, but we have proven in previous builds that you can make big power with either one.
And if you have any questions about which one would be right for your build or your power level, you can talk to the experts at Summit Racing Equipment. They'll help you pick the right one. With all of our parts final cleaned, we are going to jump into the assembly process, and the first step is to measure our vertical oil clearance on the main bearings. The main caps are installed with a new set of 10 thousandths undersized bearings and are torqued in place just like final assembly. We can set our SPI micrometer to the rearmost main journal size and then zero out the dial bore gauge to that measurement. Our dial bore gauge then gives us a direct oil clearance measurement inside the bearings, and they all come out between 23 and 25 10,000ths.
The same process is repeated on the connecting rods using our ARP Rod Vise. First, the ARP 2000 rod bolts are torqued to 85 pound-feet and checked for the proper amount of bolt stretch at 60 to 64 10,000ths. Then the micrometer is set to the corresponding rod journal size and used to zero out the dial bore gauge so it can be used to measure the oil clearance for that crank throw. The process is repeated for all 6 and they land between 20 and 22 10,000ths.
All right, we have gone through and set all the clearances on our 300, and we know we don't have to do any more machine work. So we've got everything final cleaned, and before we start clicking it together, what we're gonna do is paint it. We're gonna be using P.O.R. 15's engine enamel in gloss white. We love the way this engine looked before, but some of our paint got pretty beat up on the installation process and in the jet washer, so we want to revitalize it, give it that nice clean look. So we got everything final cleaned and in the paint booth, taped up, ready to go. First, we're going to be hitting it with their rust preventive coating. This is going to give us an even base color and protect all the bare metal surfaces from corrosion in the future. Then we will come back with their white engine enamel. The reason we love using this stuff is because it lays down super smooth and super glossy, and it has a finish that's gonna last a long time. It's super resistant to oils, greases, fuel, even things like brake cleaner. It holds up extremely well.
After thoroughly mixing, not shaking, the P.O.R. 15 Rust Preventative, we can pour it right into the paint gun since it does not need to be thinned out to be sprayed. We will lay down a few coats of the gray coating in order to get an even and full coverage across all the parts before letting it flash off while we prep out white paint.
A light first coat is used to help get good adhesion and full coverage, followed by a few medium coats to give everything a consistent, glossy, and beautiful look. We have got everything out of the paint booth, untaped, and it's pretty well cured. We have made some serious progress today. We've got a lot of modifications done, and we are looking in good shape to get this thing together.
But unfortunately, we have slim run out of time for this session. So the next time we pick this up, we're gonna be sticking all of our cool parts in, and we're gonna definitely see how much power we can pick up on our Ford 300.
Yeah, and if you want to see more about this build or any of its previous versions, you can always check it out on Power Nation TV.